Hi, I'm Dallas Briscoe, and I'm here to talk to you about muscle contraction. The first step in muscle contraction is that your brain sends a signal to the muscle fibers so you can complete an action. This signal is transported out of the brain to the muscle fibers where it's relayed by motor neurons. The signal arrives in the neuromuscular junction, which is here, where a motor neuron transmits the signal to the muscle fiber, therefore starting the process of muscle contraction. If you take a closer look at the muscle, then you'll see a structure like this. It's made of two proteins called myosin and actin. Together they form contractile filaments of muscle cells. Lines of myosin proteins grab onto actin and pull them inward, therefore causing the muscle to get shorter and contract. Unfortunately, there are some factors that prevent this from happening. The first is that there's a barrier called tropomyosin, which is this pink thing. The barrier prevents myosin from attaching to the actin. There's a process to moving the tropomyosin out of the way. First, there's a structure called the sarcoplasmic reticulum. It acts as a storage unit and regulator of Ca plus 2 ions, or calcium. You get calcium by eating dairy products, beans, and salmon. Once it's in your body, the sarcoplasmic reticulum releases it and is used as fuel for a globular protein called troponin, which is this red thing. The active sites are then exposed, but nothing happens because the myosin needs fuel to move the actin. This fuel is called ATP. ATP comes in the food we eat. The food is then converted into glucose, which is broken down with oxygen to form ATP molecules. The ATP travels through the bloodstream and is used by the myosin to fuel the movements that contract the muscles in your body. It goes here and fuels the myosin. Actin and myosin contract all the muscles and organs in your body. Some are voluntary movements, like moving your arm or leg. Others are involuntary, like the contraction of your heart and stomach. These processes continue throughout your entire life, and the muscle just contract and relax. This can be seen here. There's actin, which is orange, and the myosin, which is blue. The myosin pulls the actin towards itself. This relaxes so it's further apart. Then, whenever it contracts, they get closer. It relaxes and contracts, relaxes and contracts. After an extended period of time, this process wears down the body and you die. This is when rigor mortis sets in. Rigor mortis can be defined as the stiffening and inflexibility of muscles after death. This process occurs because you're no longer intake ATP, so it's depleted from your bloodstream. It goes away, there's no more ATP. Without ATP to fuel the movements in your body, the myosin remain frozen where they are. This event results in certain muscles remaining either contracted or relaxed, and they stay that way until your cells start to decay, and it usually takes up to 72 hours. After this, your joints unlock and your muscles relax. Thank you so much for watching. I just want to cite my sources and credit. I use these sources to make my project, and I also use cardboard, colored pencils, colored paper, markers, tape, glue, pencils, scissors, and popsicle sticks.